In this problem, we're going to look at the organic loading of a trickling filter. Let's go to the board and see how to work this problem. The problem reads, a trickling filter wastewater treatment plant receives a flow of 1.95 million gallons per day. Calculate the organic loading to this plant if it has a 135-foot diameter trickling filter with a 5-foot media depth and has a primary effluent BOD concentration of 110 milligrams per liter. Well, like always, we want to pull out our known and our unknown information. So they tell us that we're looking for organic loading, and that's going to be BOD, or biochemical oxygen demand, pounds per day per 1,000 cubic feet of media volume. And that's important. We need to use 1,000 cubic feet as a unit in this problem. So we're looking for pounds per day of BOD per 1,000 cubic feet of trickling filter volume. They tell us that plant flow is 1.95 million gallons per day, so we write that down. The diameter is 135 feet, so we write that down. And it has a 5-foot media depth. We'll want to include that in our known information. And then they tell us that the BOD concentration is 110 milligrams per liter, so we write that down. Well, now that we have all this information pulled out of the problem, we'll use our organic loading rate formula to solve it. And notice that organic loading on this trickling filter is equal to the pounds per day of BOD going to the filter divided by the volume of the filter in 1,000 cubic feet. And I'm going to emphasize that 1,000 cubic feet has to stay as a unit. Well, first thing we'll do is we'll find our pounds per day of BOD going to this trickling filter. So using our pounds formula, we plug in the numbers of our flow, the concentration, times 8.34. So as you see, we plugged in 1.95 million gallons per day times the concentration of 110 milligrams per liter times 8.34. So we see that we're sending 1,789 pounds per day of BOD to the trickling filter. That's going to be our top number in our formula. Well, now we got to calculate the volume of our trickling filter. So we use our formula that says volume equals 0.785 times the diameter times the diameter times the depth of the trickling filter. So we'll plug in our numbers. Our diameter is 135 feet. We use that twice. And the depth is 5 feet. So when we do this math, we find that we have 71,533 cubic feet of volume in this trickling filter. Well, we need to factor out 1,000 cubic feet from that 71,500. So that's the same as if we were to take 1,000 cubic feet times 71.533. So basically we just divided our total volume by 1,000. We divided that 1,000 out. So we have 71.533 times 1,000 cubic feet. And we're going to plug that into our formula in this way so we can use that 1,000 cubic feet as a unit. So when we plug this into our organic loading formula, we have our 1,789 pounds per day of BOD on top, and we divide that by the 71.533. We're going to leave the 1,000 cubic feet there. So when we divide 1,789 by 71.533, we get 25 pounds per day per 1,000 cubic feet. So the organic loading is 25 pounds per day per 1,000 cubic feet. And that, my friend, is how this problem is solved.